Every morning, millions of people pull on a pair of Adidas sneakers without thinking about what went into them. They get worn on sidewalks, gym floors, school hallways, office commutes, and weekend runs. But before one pair takes its first step, it has already passed through cutting machines, heated molds, glue tunnels, stitching lines, and inspection tables. Let's follow one pair from raw material to finished box. The process begins with materials arriving at the factory gate. Trucks unload rolls of mesh fabric, recycled polyester yarn, synthetic leather sheets, rubber blocks, foam pellets, thread cones, laces, labels, cardboard boxes, eyelets, and drums of adhesive. Before anything enters the line, workers inspect it. They scan barcodes, weigh rolls, check batch numbers, and compare color cards under bright lamps. A fabric roll that is too thin, too stretchy, or even slightly off color can ruin thousands of shoes. So it is stopped before cutting begins. The approved materials move into storage rooms where temperature and humidity are controlled. This is not just for neatness. Moisture can change how fabric cuts, how glue bonds, and how foam behaves. Some materials rest for about 24 hours, so they adjust to the factory air. Adhesives are kept in a separate safe area because heat and open flames can affect them. Every batch is tagged. If a shoe fails a test later, the factory can trace it back to the exact rubber, foam, or fabric used. For knitted Adidas uppers, the first real machine is a computer-controlled knitting machine. Cones of polyester yarn feed into rows of fast-moving needles. The machine follows a digital pattern for each size. It can make the toe area soft, the midfoot tighter, and the ankle collar more flexible, all in one piece. A single upper may take several minutes depending on thickness and pattern. This method reduces waste because the machine creates a shape close to the final upper instead of cutting many pieces from a flat sheet. For panel-based sneakers, production moves to the cutting room. Rolls of fabric, suede, synthetic leather, or mesh are spread across long tables. A nesting program arranges each shoe part so the factory wastes as little material as possible. The toe piece, side panels, tongue, heel tab, collar lining, foam padding, and stripe overlays are all mapped out. Automatic cutting machines use vibrating blades or lasers to cut the shapes. The blade moves with computer accuracy, often making thousands of tiny movements per minute. For thick material, a hydraulic press pushes a steel die through the sheet with several tons of force. After cutting, workers sort the parts into bundles by size, color, and left or right shoe. They check for stains, weak coating, frayed edges, bad grain direction, and uneven thickness. A small flaw at this stage becomes very visible later, especially on the toe or side panel. Defective pieces go into reject bins. Good pieces move forward to printing, heat pressing, and stitching. Branding and overlays are added before the upper is closed. The three stripes may be stitched, printed, welded, or heat pressed. A heat press uses flat heated plates, often around 120 to 160 degrees Celsius, to bond film or logos onto fabric. The part sits under pressure for a few seconds. Too little heat and the logo can peel. Too much heat and the material can shine, shrink, or burn. Operators check the edges to make sure the mark is sharp and firmly attached. Now the upper pieces reach the sewing line. Operators sit at industrial sewing machines, each trained for one task. One stitches the tongue lining. Another attaches the eye stay. Another joins the side panels. Industrial machines can run at several thousand stitches per minute, but the worker controls the path by hand. Some seams use double rows for strength. Others use flexible stitching where the foot bends. The goal is to make the upper strong without making it stiff. As the upper grows, foam padding is placed around the collar. A heel counter, usually a stiff plastic piece, is inserted into the back. This keeps the heel area upright and helps hold the foot in place. Some shoes also get a toe reinforcement layer to protect the front shape. Workers trim loose threads with scissors or hot knives. Then the upper may pass through a metal detector. Broken needle pieces are a serious safety risk, so factories track needles carefully and inspect for fragments. At the same time, the sole department is making cushioning. The midsole starts as foam pellets or a mixed foam compound. EVA foam is common in many athletic shoes. Pellets are mixed with color, blowing agents, and additives, then loaded into molds. Heat and pressure expand the foam into the midsole shape. Many foam molding processes use temperatures around 160 to 180 degrees Celsius, depending on the formula. After the mold opens, the hot midsole is placed on cooling racks so it does not wrap or shrink. Some Adidas shoes use expanded thermoplastic polyurethane cushioning, known from Boost-style midsoles. Tiny pellets are steamed until they expand, then fused together inside a mold. The result is a midsole made from many small capsules that compress and spring back under the foot. Other models use lighter foams designed for speed and lower weight. Each midsole is checked for weight, density, size, and surface finish. A digital scale can match a foam part that expanded incorrectly. A gauge checks whether it matches the correct thickness. The outsole begins with rubber mixing. Natural rubber, synthetic rubber, silica, carbon black, oils, sulfur, and pigments are measured and fed into large internal mixers. The mixer kneads the rubber under heavy pressure until the ingredients spread evenly. The rubber comes out warm and is rolled into sheets by a calendar machine. These sheets cool, rest, and are cut into blanks. Each blank goes into a heated outsole mold. The outsole press closes under high pressure. Inside the mold, the rubber cures at roughly 150 to 170 degrees Celsius. This changes it from a soft compound into a tough, flexible outsole. The tread pattern, logo marks, flex grooves, and edges form during this step. When the mold opens, workers remove the outsole and trim off extra rubber squeezed around the edges. This extra edge is called flash. A rotating trimming tool or sharp knife cleans it away. Outsoles are inspected before assembly. Workers look for air bubbles, missing tread, uneven color, weak edges, and warping. A hardness gauge presses into the rubber to measure firmness. If the rubber is too soft, it can wear out quickly. If it's too hard, it may lose grip and comfort. Random samples go to abrasion machines that rub the outsole against a rough wheel to predict wear. Now the upper and sole are ready to join. First, the stitched upper is pulled over a foot-shaped mold called a last. The last gives the shoe its size, width, toe curve, and heel shape. Lasting machines use metal pincers to grip the lower edge of the upper and pull it tight. Toe lasting shapes the front. Side lasting tightens the middle. Heel seat machines form the back. Heat or steam may soften the material so it holds the new shape. The bottom of the lasted upper is prepared for glue. A roughing machine uses a rotating brush or sanding wheel to scuff the surface. The midsole and outsole bonding areas are also roughened or treated. This step matters because glue grips better on a textured surface than on a smooth one. If this is skipped or rushed, the shoe may separate after use, even if it looks perfect at the factory. Adhesive is applied by brush, roller, spray gun, or automatic cementing machine. Many factories use water-based glue to reduce fumes, but ventilation and protective gear are still used. The glued parts move through a drying tunnel with warm air, often around 50 to 70 degrees Celsius. The goal is to remove moisture and activate the bonding layer without overheating the materials. Next comes sole attaching. The worker lines up the upper, midsole, and outsole using guide marks. The toe must sit centered. The heel must sit straight. The sidewalk must follow the upper evenly. The shoe is placed into a sole pressing machine. Rubber pads or air bladders squeeze the sole against the upper from all sides for several seconds. This pressure helps the glue spread evenly and locks the parts together. After pressing, the shoe stays on the last while it cools and sets. Then the last is removed. Workers clean glue marks, trim threads, brush the surface, and check the shape. Insoles are inserted, laces are threaded, size labels, hang tags, and tissue paper are prepared. At this point, the sneaker looks ready, but the inspection stage is still ahead. Quality control compares every pair to an approved master sample. Inspectors check logo placement, stitch spacing, toe shape, heel height, color match, outsole alignment, and size marking. A shoe can fail for a crooked stripe, a glue stain, a wrinkled toe, or a sole that sits 1 millimeter off center. Fit and safety checks come next. A size gauge checks inside length. Workers press the heel, twist the sole, flex the forefoot, and feel inside for sharp seams or lumps. Metal detectors may be used again near the end. If anything feels wrong, the pair is repaired or removed. Approved shoes go to packing. Paper is stuffed inside to hold the toe shape. Tissue wraps the pair to protect the surface. The box label is matched to the model, size, color, and destination. Scanners confirm the barcode. Boxes are packed into larger cartons, often around 10 to 12 pairs per carton depending on size and style. Each carton is weighed because the wrong weight can reveal a missing pair or wrong size. Finally, cartons are sealed, labeled, stacked on pallets, and scanned into the warehouse system. From there, they move to distribution centers, stores, or online order networks.